I'll create a new file, so File New. I'm not going to save this linear Fresnel model. There's our technology and market window. The direct steam power tower, this is the new model. The older versions of SAM had a molten salt power tower. So that's a system that where molten salt is pumped through up the tower into the receiver and heated, and then use heat exchangers to in the power cycle to heat the steam for the Rankine cycle. In direct steam, this steam itself is driven through the receiver, goes up the tower and into the receiver. For the power tower model, we just have utility financing options because they tend to be large-scale systems for utility power generation. And so we have the utility IPP financing option, which is sort of a simpler financial model for utility projects that involve PPA prices. The single owner financing option under advanced utility IPP option is for the same kind. You can use it to model the same type of project. So utility, IPP, and single owner are sort of equivalent financial models. The single owner one is a little bit more detailed, so you have more inputs. You can model. It has a little bit more refined modeling of makers, appreciation, and so on. So if you're more interested in the performance model, you can just use the utility IPP model. If you're a finance person and interested in more detailed financial modeling, then the single owner model might be better for you. The other advanced utility IPP options are for financial structures that involve more than one partner. So the single owner and utility IPP assume a single entity develops and operates the project, and these other options here are for options where there's two partners and that have different shares of equity in the project. I'll just use the utility IPP since I'm not talking about financing here, and type a name for my case, and create a tab with my case. And again, the first few inputs here are for the financial model. So I'll scroll down to tower system costs. So the cost page here is the same as or pretty similar to the molten salt tower system cost page. We've got installation costs in different units, and then O&M costs down here at the bottom. And again, these default values are just to help you get started. They're not based on any specific analyses or a specific project. On the field page, we specify the properties of the solar field. This is, again, pretty similar to the molten salt power tower system. Where it looks different than the molten salt system is on the tower and receiver page. So the steam receiver consists of a boiler, a superheater, and a reheater. And the recirculating boiler accepts feed water from the power cycle and generates boiling flow at a quality that you specify as an input. And then dry steam from the boiler then passes through the superheater, where solar flux heats the steam to the temperature set point that you specify again as an input. And then that steam passes through the reheat loop before passing to the remainder of the power cycle, whose properties are on the power cycle page. The power tower models, both the molten salt and direct steam models, are different than the other CSP models in that they require two steps to run a simulation. The first thing you have to do after you've specified all the costs and properties of the system is run the field layout wizard. So you click Start Wizard here and Sam runs a little program called PTGen to determine the optimal tower height and the layout of the heliostats in the field. Once you run the wizard, then you click the Run button to simulate the performance of the system and calculate the system's annual output and economic metrics. So the power tower model has some involved calculations. It takes a moment or two to run. Here's our results, our metrics table, and then we can look at the various detailed results. Okay.